My name is Jennifer Carter, and I am a science teacher at Rowan County Senior High School. And I teach a variety of classes. I teach some freshman courses in chemistry and physics, but I also teach astronomy and space systems. But in addition to that, I facilitate a dual credit course between Rowan County Senior High School and Morehead State University. So in that course, the instructor of record is aerospace engineer Bob Twiggs. And my role in the course is an on-site facilitator. So Professor Twiggs delivers a lecture via the internet twice a week, and I'm on-site at Rowan County Senior High School in the classroom helping the students understand and remediate through the material. So that happens 2 days a week, but 3 days a week we have a lab component. So we do different types of labs. We do electronics labs, we do programming labs, and overall mechatronics labs. And some of those labs are actually large-scale projects like the high-altitude balloon launch that we're scheduled to work on in the spring. So that high-altitude balloon launch mission entails the students designing and building payloads for their balloon that will be sent into the stratosphere. Those payloads could be temperature sensors, Geiger counters, pressure sensors, things of that nature. But on board are cameras and radios. And so the radios will take the data that's collected by the sensors and transmit them to ground stations on the ground where students will be able to collect the data.
One of the fun projects that we were supposed to do, and I don't know if we're going to get to do it due to a lack of helium, was a high-altitude weather balloon launch.
It won't be completely in space, but it'll be close. It'll be high enough to see the curvature of the Earth, which is pretty darn high when you think about it.
And it goes up over 100,000 feet, and it goes into the stratosphere, I believe. It's a section of the atmosphere that we really haven't spent that much time researching, so it yields fairly good data.
And we're going to put this string of projects on it, and some of them have cameras in it, some of them might have biological experiments. We're going to send them up and see what happens.
A course called Introduction to Satellites and Space Systems. And students who take this course get an introduction to the space environment that surrounds us and is relevant to our everyday lives. So they learn about the Van Allen radiation belts, they learn about the Earth's magnetic fields, they learn about charged particles that bombard us, and that can affect our daily lives with our electronics equipments and such, but also the free fall environment of space. So those are a couple of things that the students get out of it, but also the course through the lab component gives them an introduction to electronics and programming. And so today's students are high-tech students. They all have laptops, they all have iPhones or iPads or iPods or something. And they're used to dealing with technology that is all electronic and is all software driven. So this gives them the underlying understanding of the technology that is part of their everyday life. What the students learn translates across disciplines in all of their high school classes, and it pulls them into one. So it is the grand application of mathematics, of physics, of chemistry.
We've taught everything from what happens in space, the orbits, the eclipse of the satellites that go around the Earth.
I took this class to kind of get a good start on my future career in space science, because I'm still deciding between majoring in astrophysics or space science. So this class is serving as a good basic amount of knowledge to get me started.
Once the payloads have been designed and built, we have to assemble them. So we have to actually acquire the balloon, which is provided through the Stratospheric Space Science program here at Morehead State University. And their crew help us line up the series of payloads in these small boxes that are attached to the balloon. So while it's going up into the stratosphere, there are students on the ground here at Morehead State University at the ham radio shack up on the hill that operates at VHF and UHF bands. And then there are also students out in the field with handheld Yagi antennas and radios connected to their laptops. And so they're tracking the balloon as it's going up through the air and can actually receive real-time data from it. In addition to that, there is also a chase team. So once we send this balloon up and all of our payloads, we don't want to lose that very expensive equipment that we have on it, whether it be radios and cameras and payloads. So the chase team will track the balloon using GPS and actually recover it once it has landed. So building spacecrafts are not cheap. Electrical components, although the individual components themselves can be very inexpensive, once you put them all together, it adds up. And in order for the students to get a good solid foundation in systems level engineering, they need to work through multiple types of projects with multiple types of equipment and components, such as electrical components and all the equipment for testing electrical circuitry, but also in the programming world too. There are costs associated with both sides, and we need additional funding for not only what they use in the classroom, but when we go out of the classroom and apply what we've learned in activities such as high altitude balloon launches and potentially placing an experiment on the International Space Station. It takes money. So it takes money to buy a launch, to get our experiment on a rocket, to get to the International Space Station. And so once the balloon has landed and we've collected our data, then we can reduce our data into a usable format to be analyzed, and we can share that data with other classes that might be interested in that data. For example, our Earth and Space Science class would be interested in the temperature difference as the altitude changes for the balloon. Or other courses that may be interested in the data might be a physics course that's studying radioactivity. So if we have a Geiger counter on board that's collecting data on the charged particles that are present as the altitude changes, then we can provide that data in a package to that class to analyze.